All right, time for another graph, everyone. But for this one, we're going to need some actual data. You have a couple options for this. Option one, if you keep watching this video, I'll show you an experimental setup and I will give you a set of data points that you can use. Just pause your screen, write them down, copy them into your spreadsheet that you can use for your experimental data. They are real data collected by me for the experiment. Option two, if you would like to do the experiment yourself, you can set it up somehow using objects around your house. It doesn't have to be Hot Wheels. It can be anything that rolls down a ramp and then leaves from a table horizontally before reaching the floor. Remember, the only measurements you need to make are the height of the ramp on the table and then the height of the table down to the floor. If you choose to record your own set of data, just make sure you get 5 data points. And because that's a little bit more work, if you take a picture of your experimental setup that you made, so I can see that you did it yourself, I'll give you a couple bonus points. Why not? Just send me either on email, Schoology, whatever, a picture of your experimental setup, and I'll give you bonus points. But if you don't have time for that or you don't have materials in your house, no problem. You can still get a cool 100% as long as you follow all the directions. Your graph is complete and you use the data from the video. So I'll show you my setup here and then put some data points on the screen. Once I put those on the screen, make sure you pause the video, write them down, take a screenshot, whatever, because you'll need those for your graph. And then if you keep watching the video, I'll go through how to make that graph. I'll do a sample graph for all that stuff. I think that's it. If I forgot anything, you will just see it magically appear in the video in the future. See you there. Okay, here is a great experimental setup. Couple features I want to point out. So notice we have the whole thing set up on a table. We've got a track. The shape of the track doesn't matter. The length of the track might in terms of real world physics if you start worrying about friction and things like that. We're not going to take any of that into account into our calculation. So all that matters is the launch height, the release height. And then another really important thing is if you're going to try to construct this yourself, make sure the track levels out before it leaves the table. If you have it set up so it's either angled up or angled down, that'll not line up with the derivation that we did, and the calculations won't work. You can calculate it, but it's a whole lot more complicated, so we don't really feel like doing that. Last reminder, make sure you get the table height, but when you're measuring it, measure to where the track is. So if the track is like above the table at all, make sure you're measuring to the track, not just the height of the table itself. And then measure your vertical height this way. When you're measuring for little h in the equation, you should be more or less straight. There we go. That looks a little better. Straight up and down. When you're measuring your height, you just want the height from here, not along the slope or anything like that. Other than that, let's collect some data. There are actually going to be 2 new skills that we're going to practice with this graph. First, we are going to use a formula to calculate some predicted ranges for us. Formulas, if you haven't used them before, are a great way to save you time. Calculations that you have to do over and over again. If you use a formula, you don't have to pick up a calculator. Makes your life really easy. Secondly, we are going to have to put 2 data sets on the same axes on our graph, which is another thing you have to be a little tricky about with Google Sheets. So let's start with our formula. We are going to add a column. So first of all, this data came from the video. I did not do the experiment myself, so I just took the data that was provided in the video. Yay. Now we get to find out how good it was and or if it deviated from what we predicted with our equation. So much fun. I can't wait. So notice that I labeled our release height as little h here because in the equation that we derived, little h was the release height, how high the hill was. And then the table height, which was the same for all of them, was big H, and that's down there. So let's add a column here, maybe predicted range. And that can also be centimeters. So basically, we have to come up with a way of telling the computer that we want it to use our formula that we calculated, which if you remember, back to the other video, back to your derivation, look at that piece of paper. Looks like it was 2 times the square root of little h times big H. Now you have to type that in a really specific way to get the right output. First, anytime you do a formula, start with an equal sign. If you don't do an equal sign, it's not going to start calculating things together. Next, 2 is the number 2. For times, use the star, shift 8. Then we want to use square root. So to do that, type in SQRT in a parentheses. So then in these parentheses, we're going to put everything that we want it to square root. So first, we want to multiply little h, which is going to be different for all of our trials, times big H, which is going to be the same for all of our trials. So how we're going to do that is just click this cell for little h. So that's 50. And notice how it puts in A11. So that's telling us which cell it's referencing. You'll see why we do it that way in a minute. Times big H. Because big H is the same every time, and we want it to always multiply by 75 because it's the same table and it's the same height, here you can type in the number because that's going to be the same every time. We didn't do that over here. I'm making a physics video. Call me later. We didn't do that over here because this number is going to change every time. And I'll show you how that works in just a second. So this is going to do 2 square root of this cell times 75. And go ahead and hit enter. And boom, we've got a number. So it looks like our equation said we should have gotten a range of 122 centimeters. We actually got a range of 107 centimeters, which is not that bad. Okay, so that was cool. We still had to type in a bunch of stuff. How did that save us any time? Check this out. You can either copy this formula, Control C, and then paste it into these cells, Control V, or you can highlight and then click this little box on the right, and you can drag it down, and look what it does. So as I start on the first cell, that's what we typed in, but when I dragged it down and pasted it into the other box, if you look right here, A11 became A12. So now I'm doing 2 times the square root of this height times our same table height. And then if you go down, it becomes A13, A14, A15, and it automatically does the calculation. If you know a little bit more about sheets or you're familiar with it, you could have also used an absolute cell reference down here with dollar signs if you wanted to use $A, $19. If you're not familiar with that, don't worry about it. You can just type in the height of your table and you'll be fine. Data, check. Graph, let's go. Usually, all you have to do is highlight all the data like this, insert chart, and it should give us something okay. Sometimes it gives you something scary. I guess we can work with that. And then the steps from here are going to be pretty much the same that they were before. So we probably want to scatter. We can use a scatter chart for this. Looks like we have to clean up our, we got to clean up our axes here. So let's go to our vertical axis chart title. You can change it if you want. Not super important. Here's our vertical. And let's call that the range in centimeters. just to clarify, and add some trend lines. Why don't we? I'll help you out with this one because, trend lines, so on and so forth. Use equation, show R squared. Please don't use a linear trend line. Hopefully that looks bad to you. Hopefully you can kind of see a nice little curving shape there. This is another one of those square root type relationships. So let's see if we can get close to it with a power series. And it looks like we have x to the 0.538 and we have x to the 0.5. So this one is a square root for our predicted range, which is good because we used the square root formula. And our actual one was very close to a square root formula, which is exactly what we would expect. Check out that pretty graph. I'm proud of it. Hopefully you're proud of yours too. I'll see you next time.